Hi everyone! In this video, we will recognize the relationship between the solutions of an inequality and its graph. Write the inequality shown by the shaded region in the graph with the boundary line. The first thing we need to come up with is the equation of the line, and we need two things to do that. We need the y-intercept and the slope. Let's go look at our graph and find both of those. The y-intercept is crossing right here at positive 3. So the y-intercept of this equation is positive 3. And the slope we can find by going from one point to another point on the graph. And to find that, it's where it's crossing through the corners of the grid. So the next point, we can come up 1, so positive 1. And then from there, we're going backwards left 1, so that's negative 1. So up positive 1 and back negative 1 to get to a corner. So we have a slope of rise of positive 1 and a run of negative 1, which gives us positive 1 divided by negative 1 is a slope of negative 1. Now that we have our two things, we have the equation of the boundary line. Y equals mx plus b, and we know that the m is the slope, so it's negative. Negative 1 times x is negative x. Plus b is the y-intercept, so it's plus 3 as it is positive 3. And this is the equation of the boundary line right here. Now we need to find the inequality of the graph. So we're going to take our boundary line and put an inequality. We will either have a lesser than, greater than, lesser than or equal to, or greater than or equal to. The lesser than or equal to and the greater than or equal to are when we have a solid line. Since ours is not solid, we will not have either of these. Now we just need to know if it's a lesser than or a greater than, because this is a dashed line here. Since we are shading below the line, this means it is less than. So we will use a lesser than sign. If it was shaded above the line, up here, then we would use a greater than sign. So our equation or inequality is y is less than negative x plus 3. Now we can verify this by using a test point. I prefer using the test point 0, 0 because it makes all of the calculations quick. Now, because 0, 0 is in the shaded region of here, we want to make sure that when we use it in our inequality, that it makes the inequality true, because it's a part of the solutions in the shaded region. So we're going to do 0 is less than negative 0 plus 3. 0 is less than negative times 0 is 0. 0 plus 3 is 3. Is 0 less than 3? It is. That means that it is a part of the solution and should be in the shaded region. That's correct, which means our inequality of less than is correct. We can also do another test point just to verify. So let's pick one outside of the shaded region. How about right here? This is the point 1, 2, 3, 4, 4, 0. It is outside of the shaded region, which means we do not want it to make the inequality true. And let's verify that. 0 being plugged in for y is less than negative times 4 plus 3. And negative 4 plus 3 is negative 1. 0 is not less than negative 1. Negative 1 is smaller than 0. So this inequality is not true, which means that the point 4, 0 is not a part of the solution and should not be shaded. And that's exactly what we see in our graph here. It is not a solution and it is not shaded, which means we did one more verification that this inequality of less than is the correct direction, and we're all done.